So last week we just have seen an overview of Spark streaming and one or two examples of running that and getting those messages into the different timestamps. And so a data stream is nothing but a sequence of RDDs. So that is the live data getting chopped up into the different batches of seconds. So what is mean by a D stream? What is a batch? And how does a D stream can be transformations? And what is a Spark streaming context? And the start and await termination? All these things we have seen. Okay. So whenever the messages are received, they get duplicated in multiple blocks, and the transformed D streams will be again recalculated on the data nodes, and if any one of them is lost, those things will be recalculated. So we talked about bit of transformations there, and fault tolerance. And so what are the different types of transformations or the operations? Stateless and stateful. So the stateless, I gave you just an idea that it's all your regular RDD operations, whatever you have learned so far. Stateful operations are a bit different that you will first time observe in the Spark streaming. So we can discuss that now. So we have seen this linking section, and so this example also we have seen. Yeah, let's start with the execution of Spark streaming architecture onwards. Okay. So whenever you run any driver program that contains driver program means, so that's the one who kickstarts your Spark context. So this is also one example of your driver program. So where you are creating the Spark conf object, and using that conf object you are creating the Spark context, and using the Spark context by just specifying the batch window, the batch size with 1 second. So I am creating the Spark streaming context. So on this, I am opening a socket text stream. That means you will be listening on this so-and-so host name and the port number socket and listening for text messages. All those things will be captured into this line. And these lines will be filtered out. And whatever that contains the error messages, only those are captured and those will be printed. So start and await termination. So this is your driver program and streaming context. So once you start your streaming context, Spark jobs to process the received data. So the streaming context will invoke some of the executors or initiate some of the executors on the worker nodes, and on those it will initiate the receiver tasks. So the tasks will be running there. So long tasks will be running on the executor JVMs. So those are nothing but your receiver tasks. So the receiver task is responsible for receiving the message from the input stream. Let's say if that is a socket text stream, so this receiver is the one that keeps listening on that socket port number. And if we have configured our Kafka or Twitter, so on that Twitter, the receiver is the one that will keep on monitoring from the source. Once it receives the messages from the input stream, so then the data will get replicated to another worker node. So as I was telling, so at least there will be 2 copies of the received data. So data will be replicated to another worker node, and then from that, so once the DStream is prepared, then the transformations or any subtasks will be executed on that. Okay, and the same one we can see in the next slide also. So if you observe, the left side one has the Spark streaming and the Spark driver, and we have a couple of worker nodes here. So whenever you submit the Spark streaming context start, yeah, so network input tracker. If it is your socket tracker, for example, I took, so network input tracker. So this will track for the input, the new upcoming input on the network ports. Now the network receivers. So for this, the network receivers launched as tasks, as I was telling. So a receiver task, receiver itself is one task in the executor. Okay, that receiver task will be running on the worker nodes, some of the worker nodes. How many ever receivers that we can specify. And this receiver will receive the data. So data received and the blocks pushed to. So once the data is received to this, so it has to be stored into in-memory, right? So to store in-memory in the RAM memory of your JVM of executor, the block manager is the one that is responsible to push those blocks into the RAM memory. And once they are pushed into RAM memory of that particular executor, and the same will get replicated onto another machine's block manager. The blocks get replicated. So once the blocks get replicated, so these will send the notification that once the block is successfully replicated, so notification of received block IDs will be sent back to your driver. So I have received so and so block ID. And here in the driver, block manager master service will be there, and so that will get notified with all the locations of the block IDs. The block manager master will get notified with all the locations of the block IDs. Okay. So that way it maintains this. This is how the flow happens between your driver and your worker nodes. And coming to the more details of the DStreams and receivers, here in the receivers and DStreams, we have 2 types: the basic sources and advanced sources.
Shiva, I have a question.
Yes.
Okay. Okay. So in the earlier slide, what do you mean by location of the block ID?
Location of a block means in which machine, in which worker node that is present. That is the location.
Okay, so you mean to say the memory location, not hard disk location, right?
No, it's not hard disk. It's not stored in hard disk.
Yeah, that is what I mean. It is not processing.
Not even memory location. In which machine that is stored in. How does your name node stores the locations of your block IDs? Does it store the location of your local file system? No. It stores only in which machine that is present.
Yeah. Okay.
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 So the machine address, so in which machine that is stored, so that will get maintained in the storage block manager master. Okay. And coming to the different input streams, we mainly have two types of input. These streams are depending on the sources. We have basic sources and advanced sources. So basic sources are sources directly available in the streaming context API, where you don't need to download any extra packages or APIs. So when you are using your Spark streaming, example, the file system streaming, the one that we have seen, text file stream, and socket connections. Just now we have seen the socket text stream, and any Akka actors. Akka is also one of the streaming collection kind of tool, but here this is our out of scope. So advanced sources like Kafka, Flume, and Twitter. So are these all these are like advanced sources, and we need an extra packages and extra dependencies while linking these into our projects, because they ship with their own licenses, different licenses. So obviously they need a special dependencies. They don't ship with the default streaming context APIs. Okay. So these are the two types. Now, whenever you have a receiver, that means for not for all types of sources a receiver task might be running. It is for sure that for all the advanced sources, a separate receiver task will be kickstarted, and some of the basic sources like socket connections also, your Spark streaming will run the receiver task on the worker nodes. Now here, so for example, file systems, it may not run the receiver task. Okay. So it may run the receiver task or it may not run the receiver task based on the sources. So as example I have given, so in this the list of sources available here. So on file systems related streaming, so it will not launch a separate receiver task on the worker nodes. Only for socket connections and advanced sources like Kafka and Twitter and all those things, it will run a separate receiver tasks on the worker machines. So whenever it runs a separate receiver tasks, so we have to be careful in specifying the master URLs, especially when you are running it in your local mode. If you just give your local or local of one as your master URL, that means, so local or local of one means it will allocate only one core CPU, to process that, and that one core means only one thread can run, and that one thread will be used for your receiver itself, but the data will not be processed. That is anyway your local mode. That will not be affecting in your real time. But coming to the real time, whenever if you are running these kind of things, if you observe how many ever the worker nodes are there with you, let's say if there are 10 worker nodes, try to so at least you have to allocate the executor num cores, the property that we have seen, right? Executor num cores, that number of cores that you allocate to the Spark streaming applications, must be more than the number of receivers that you want to run or something, or that it will get kick-started. Maybe in the first go itself you may not be able to identify that. So this is all like Spark streaming, as I was telling. It's still in incubating phase, we can say. It's still evolving. You guys have to make it a trial and error based approach. So first try allocating the 10 cores and see if that is able to process your data as fast as the data that is getting received or not. How we can identify whether my data is getting processed that speed as the data getting ingested? We can see that from the log messages. I will show you at the end of these slides. Okay. So file streams, anyway, we have seen that one example there. So last Sunday. So out of the basic sources, these are the ones, the file streams. Under file stream, the text file stream is the most famously used one. So we configure a data directory. Whenever a new files get ingested into the directory, they will get read as it is, and they will get processed and ingested onto HDFS. So this is something same as your Flume spooling directory source, correct? Isn't it? In your Flume spool directory source, if you configure a directory as an input, whenever a new files are ingested into that, so those files will get copied onto your HDFS without any processing. But here, with the help of Spark streaming, you have configured the same directory, and whenever so it could be your local and as well as your HDFS. So here in this case, if I give my HDFS directory, so whenever a new file is ingested into that, it will process and ingested into wherever you want to ingest. Or if it is a local directory, it keeps monitoring into that. So since Spark has support to read all the file systems that has HDFS support, and out of which even your local file system is part of it. So it can read from your local file system and similarly act as your Flume spool directory source, and along with that it can process, it can transform, it can do the basic transformations and then ingest the data onto your HDFS. Okay, and one good thing is that file streams do not require a running a separate receiver task, hence does not require allocating cores for your receivers. Otherwise, your receiver is a continuous task that will be running, so it needs a dedicated thread to be available there. And so few points to remember about the data directory. The files must have the same data format, so if they need to be processed in your Spark streaming, otherwise you will get casting exceptions. The files must be created in the data directory by atomically moving. That means one complete file you have to move it there, but not like you just start opening a file there, just created an empty file and start writing into that file. That's not the case. Even this, so these are like the same dependencies or the same constraints for both Flume and here as well. Okay, so even in Flume the same constraints. So you have to move, the files should be moved atomically, renaming them into the data directory completely into that. So once moved, the files must not be changed. Once the file is moved into the directory, it should not be changed. Okay, so yeah, any data appending into those files, that will not be read. So if you keep on changing. So that is the basic source, and socket connection source also I have shown you an example. Coming to the advanced sources, so you can connect to Twitter, you can connect to Kafka. So Kafka is one of the streaming source that we will see. And so anything these advanced sources, you need an additional dependency both for your Maven or SBT building. So in each of them, you will have its own utils classes. For example, in Twitter, you have Twitter utils, and in Flume, we have Flume utils classes. And in Kafka also, you'll find similar to this Kafka utils that we'll discuss anyway while discussing the Kafka tool. Okay, now, so using these utils classes, on these utils classes, we have a create stream methods available. So this is the one that is responsible for taking the Spark streaming context object and any additional properties, the parameters that this Twitter utils or the advanced source utils will take, and returns the DStreams for us. And once we have the DStream, only these two lines that will differ for basic and advanced sources. And remaining all the lines will stay common. So once you get the DStream, from there onwards your process will continue as usual. Okay, so let me complete this basic kind of points and the stateful operations also. Then I will show you that advanced source, one of the advanced source Twitter, and some of the stateful operations. We'll see that example. Okay, now, so these are the different sources, basic and advanced sources. And coming to the receivers, again we have two types of receivers. So one is a reliable receiver and another one is unreliable receiver. A reliable receiver means that is the one that sends the acknowledgements to a reliable source when a data has been received and stored in Spark with replication. Okay, once, as I have shown you in the previous slides, once the blocks are received by your receiver and replicated onto another machine, then if that receiver sends an acknowledgement back to your driver or the source, not to the driver, it should send to the source, then that is called as, those type of receivers are called as reliable receivers. If it is not going to send or not support, if it does not support the acknowledgements, then it is not called as a reliable source receivers. And for example, maybe, I mean, sometimes you may face like the file streaming sources. They are not, they don't expect a reliable receiver to be happening there. First of all, they don't have receivers at all. So automatically the worker, the streaming itself will create the streams. It doesn't need a separate receiver thread. The streaming context itself will start reading those files. Okay.